In TypeScript, there are several different data types. These data types are Boolean, number, string, undefined, object, and function. First, let's take a look at the Boolean data type. The Boolean data type is very simple. It is either the value true or the value false. So let's go ahead and create a variable. We'll call it my variable equals true. Now we can use the type of keyword to check what the type of this variable is. So we'll say console.log type of my variable. And when we run this application, we should get the word Boolean printed to the console. So we'll say npx tsnode source o2 types.ts. And we get Boolean printed to the console. If we change this to false, we should still get the word Boolean, because false is also a Boolean. Now let's take a look at the number data type. Unlike some languages, there's only one data type for numbers in TypeScript. This includes both positive and negative numbers, as well as those with and without decimal places. So let's take a look. We'll say console.log type of, and we'll give it just a whole number. And then we'll also say console.log type of, and we'll give it a decimal. And we'll even make it negative. Now if we run this, we should get the word number printed twice to the console, as both these numbers are the number data type. And we can see both these values have the type number. We will skip over the string data type for a moment and look at undefined. Undefined means you're trying to access a value which has not yet been assigned. To see this, let's create a variable. We'll say let a, and we won't assign it a value. Now if we say console.log type of a, we should get undefined printed to the console. And we see that we get undefined printed to the console. We have already seen the string data type in some of our previous examples. However, there's actually more than one way to create a string. We can use single quotes, double quotes, or template literals. For single quote and double quote, there's almost no difference between the two. So let's take a look. We'll say console.log and type of, and we'll create a string hello world with double quotes. Then we'll say console.log type of, and we'll create a string with single quotes. And when we run our application, we should get the word string printed twice, as they're both of type string. When working in web development, it's more likely that we'll need a double quote inside of our string than a single quote, so personally I tend to favor using single quotes. Let's consider the string Blake said hello. If we want to do this using double quotes, we'll have to say Blake said, and we'll have to escape our double quote with the backslash. However, if we use single quotes, it's going to be much easier, as we won't have to escape the double quote character. And when we run this, it should print Blake said hello for both of them. The third way to create a string is with template literals. Template literals use the backtick character, and there are two important distinctions when using them. The first is that template literals can span multiple lines. So let's create a string with multiple lines. My string equals backtick, line 1, line 2. And then we'll print this line to the console to see that it prints with multiple lines. The second, and arguably more fun distinction with template literals is that they allow for string interpolation. String interpolation effectively allows you to inject TypeScript code into your string. So let's try it out. First we'll say const a equals 5 and const b equals 10. Now within our string, we're going to change it to say a equals, and to use template literals, you say $ and then bracket, and you can inject TypeScript code directly into your string. So say a equals $bracket a, b equals interpolate b, and then a plus b equals interpolate a plus b. Now when we run this, we should see a equals 5, b equals 10, and a plus b equals 15. Template literals are very useful in certain cases. However, if your string is not multiple lines and you're not using string interpolation, you should not use template literals, as they will be slightly less performant. Now let's take a look at objects. Objects are a pretty vital part of many programming languages. They allow us to group information or functionality into a single location. We will be using objects a lot. In its simplest form, objects are just a group of key value pairs. For example, if I wanted to model information about myself, let's see how that would look. We'll say const myself equals, and then we'll use curly brackets to create the start of our object here. And we'll say first name is Blake, where first name is the key and Blake is the value assigned to that key. We'll say last name equals Krupa, where again, last name is the key, Krupa is the value assigned to that key. And then we'll say favorites, programming language, which is by far going to be TypeScript. Now, if we print this to the console, we'll say console.log, type of myself, and then we'll also just print myself to see what it looks like. Now we can see the word object here. This is for type myself. And then we can actually see the object, which has all of its key value pairs. To access information stored on an object, we have two notations that can be used. The first is dot notation. For dot notation, it's pretty simple. We're going to change this to say console.log myself.firstName, where myself is the object variable, dot as in dot notation, and the field that you're trying to access. So let's run this. Let's save our changes and run this. And we'll see that it prints my first name to the console. The other notation we can use is bracket notation. Bracket notation should only be used in special cases. For now, those special cases might not make too much sense, so let's just look at how we use bracket notation. In our example, we're going to change this to myself and then bracket, hence bracket notation, and we're going to give it a string with the value of the field we want. So we'll say favorite programming language this time. Now when we run this, we get TypeScript printed to the console. The last data type that we have not yet talked about is function. We're not going to talk about it much now because there's going to be a full lesson just on functions later, but let's verify that the type exists. We'll say function, my function, and then we're going to say console.log, type of, and my function. And when we run this, we should get the word function printed to the console as the type is function. And that concludes our lesson on data types in TypeScript.